Okay, I will stop sharing. Okay. So anyone know what is a Spark, why it is used, how it is fitting in our big data? Anyone wants to add? Okay. Someone is speaking, I could not hear. Okay. So Spark is again, it is one of the components in big data analytics. When we consider the data storage part and do the processing on the data storage, we can also include the Spark. Okay. It works the same like it has its own architecture and it works the same like the Hadoop infrastructure where we do a map reduce job, whereas here we do a transformation and actions job. Spark is developed in not in parallel but separately, a lot with Hadoop. Okay, it's a separate architecture. So to do the map reduce job only, the Spark is also developed. It will work faster also. The data which will be stored in Hadoop in the HDFS, that is not the way in Spark. It will be stored in the memory. So processing from the memory in and out is faster. No, same like in our HBase. HBase we store it in a temporary memory, right? So it will be faster. That's why processing with the Spark is faster. But underlyingly data storage when it comes, it uses the Hadoop itself. Spark is a replacement for the MapReduce jobs, not for the distributed architecture. Okay. So furthermore, it is the processing engine. But MapReduce is also a processing engine, right? The data which we give into the HDFS, which we have it in our in our hand, the user, that will be go into a MapReduce job, and it will be converted into a different set of data frames. That also we can call it as a data frames, which will be given as output to the user. Similarly, Apache Spark is also a processing engine, but instead of doing a mapper and a reducer job, it does other operations like a transformation and actions. We can see what are those like a transformations and actions in a little while. Okay. And operations can be arbitrarily combined in order, same like aggregation and everything we do uh, s- in a map reduce job. This is also possible. So what all supported for the MySQLs are like a joining, uh, what else, grouping, aggregate, all are also supported in Spark. Also it is open source software. It is like a different, not an alternative to Hadoop, we cannot say it directly, but a different, some other group of a team has worked on a Spark to develop a replacement to MapReduce, and say that it works faster because it is going to use the memory. It also supports Java, Scala, and Python. Python is another programming language, know it. Java along with Java, and Scala is also another programming language written in order to run your Spark jobs, we can use that. Okay, so how the constructs will be here will be like here we call all our input in elements in HDFS as inputs, right? Input splits or input formats, right? Similarly, in Spark, we can call them as resilient distributed data sets. So one original concept will focus on, okay, later we can see this. So this is how we call the individual data elements as the resilient distributed data set. So more recently added the data frames which are also part of the uh, resilient RDD. We call it in short as RDD, data frames and data sets. The thing is, these are the APIs which shall be used to divide your data into smaller formats. Okay, so this is the latest one added, whereas these are the ones which were there already. Same like when Hadoop has come into picture, then Hadoop and MapReduce was working, not not anything else. Big Hive, HBase, or what else is there? Scoop. Nothing was there into picture, no. Then later on, each and every company, according to their interest, written programming languages or the data processing units or the flow units, uh, everything as per their needs they have written. Similarly, here Spark also, it came originally with a data set. Whatever the input which we give, that will be called as a RDD data set. Okay, based and after that they have come up with the data frames and data sets also. Okay, so this is the flow. Like Spark uses memory instead of the disk. That's why obviously from RAM, if you take it, it is always faster, right? It is more faster than the Hadoop infrastructure. So iteration, the pictorial representation of HDFS, like iteration, how it is happening. Like a read, it will go into an iteration and write into the HDFS. A read and write time, which takes will be, it will go every time into the HDFS. It is like a HDFS in the sense it directly goes into the memory. Memory is the hard disk where the actual data is stored and retrieves and gives the values. Whereas in Spark that is not the case. So it is all with the RAM memory, which is easily accessible memory. RAM in the sense I can say that it's a cache memory also. We can consider that way also. Okay, that is the reason Spark is very fast. This is some comparison between Hadoop, MR, and Spark. So when I say Spark, it is for MapReduce. You have can use it Spark also. If you don't have to write a Java code to do MapReduce job. But if you wanted a faster environment, which gives the faster output, then you can go for the Spark framework. Okay, data size. This can take off this much data size, and this one how the results will be three times faster than the Spark. Spark three times faster with 1 by 10th of the nodes. That is the major difference. Three times faster output you can get it. Okay. Throughput in this the output which you can get will be in Hadoop MapReduce job. It will be 3150, whereas in the Spark it is 6018. Sorry, 618 gigabits. So sort rate, all this I mean they have given the elapsed times also. Spark, it will only take 23 minutes to fetch the data from the database and give it to the user, or do the transformation jobs and give it to the user. But it is not the case with Hadoop. That's what they are saying it. Okay, so this is all the theory part. Okay, Apache Spark supports data analysis, machine learning, graphs, and streaming work. So this is the architecture. In the architecture, it also supports for Hadoop. In order to support all the things, we need a different databases. For HBase, for a different type of database which is column family supported, then we used HBase. But the Spark architecture itself will support different things like graphics, or streaming data. It can work both on with streaming data also and the static data or the flat files also. Okay, so Spark SQL is there for doing working on with the SQL kind of databases, and Spark streaming data and ML machine learning libraries also comes with Spark. So that's what the project which you are doing. You can also write PySpark, Python Spark programs to run your ML. I mean to get the output from the ML itself, machine learning output. Okay, and graphics when it comes to the graphs. So supports data analysis, machine learning, graphs, and streaming data. Okay, allows development in multiple languages. All these languages are supported in Spark. HDFS, which is the base, HBase, Hive, everything. Okay, so you can write your Spark programs to make a work in Scala, Java, and Python, R, and SQL also is supported. Java for the earlier version it was supported. I think now it is not much used with the Scala or with Python. You can write. I mean, it is more active. Spark environment is more active with the Scala and Python. Okay. So I may show some programs in Python, PySpark. Okay. In the next class I will do that. So what is this resilient distributed data sets? Which is nothing but it's kind of a containers where the data is getting stored. All the different data processing components in Spark share the same abstraction called RDD. So where there in our Hadoop we call it as an input formats, all the data information. Here we call them as an RDD. Okay, and as application share the RDD abstraction, you can mix a different type of transformation to create new RDDs. So it is like if the information which are stored in the distributed architecture, no? So you can take it from a different location itself and represent it as a single RDD and start your transformation jobs. That is what it meant. Okay, so the transformation jobs, if we say like sorting, filtering, dropping, anything you can do. And if it is an actions, if we say that what is the transformation job, which is nothing but with the data set, we can do a sort kind of thing, which we do it in SQL, or a filtering of the jobs, or grouping of the jobs, not jobs, grouping of the data that you can do it. And in the action part, I think that is coming later in the slides. It is fault tolerance also, like since it is put in a distributed architecture, it will be available in many cluster devices also, so you can use this. It is fault tolerant. RDD you can think of as a data containers, the input which shall be stored in the data containers. Okay, any doubts still now? Guys, any doubts till now? Is it okay? Is it clear? What is Spark? Why are so silent? Is it okay? What is Spark? Yes, ma'am. Okay, Jay Chandran has told. Okay, no doubts. So you understand, like Spark is a kind of is a replacement for the MapReduce. Okay, a different architecture which works faster than the MapReduce jobs. That way you can remember it. Okay. Furthermore, just a moment. Okay, so what are those data frames? It's further the division of your data into a different data sets. So it's a smaller units you can think of. smaller units which will be organized in the named columns. So data frame is one of the other distributed data sets. So you can forget like how your data sets will be there in HDFS. You can concentrate on how your data frames or the data sets will be there in Spark when you are using the Spark architecture. Okay, so that data thing, data, you can call it as the data frames, which are further divided, which are further subdivisions of the data itself, the input data itself. Okay, similar to the relation database, Python pandas data frames or the R data tables. So whatever you have worked with the Python pandas and all of those data frames, you can imagine those as your data itself in Spark also. So immutable once constructed, you cannot change it. Once that data frames are constructed, you cannot change it, and it will have a track linkage, enable distributed computations. So it will work on top of the any distributed architecture. So it enables the distributed computation also. So how to construct data frames? Read from the files, transform the existing data frames, that's a Sparks or Pandas information, and parallelizing a Python collection list and apply transformation and actions. So this is how we do construct the data frames, which will be our output after we give the data set. Okay, this how do we do that? This while you are doing an exercise, installing in the PySpark, then you will know it. It's just the steps which is given over here. Okay. Okay. So RDDs versus the data frames, what are those? It's a low level interface into the Spark, whereas the data frames, it will have a schema. So data frames, that's that same like in a Python and Panda, you can imagine that it will have a schema data. I mean how the structure of the data will be, whereas the RDD is the low level. So this whole data set which you are coming for the map reduce job, here it is a Spark job itself is the RDD. Okay, from that your data frame is created, which will have a schema like how the data is written like that. Data frames are cached and optimized by Spark. Data frames are built on the top of RDDs and core Spark API. This is going to be the output from your Spark uh, architecture. Say for example, if we have this Hadoop HDFS, this is HDFS, you can imagine, over which this mouse is not proper. I'll just change the mouse 1 minute. Okay, okay, sorry about that. Okay, HDFS, over it you can think of that you have MR job, but instead of MR we are going to have the Spark framework. Okay, so this Spark, the input to the Spark will be these RDDs, over which we will be generating the uh, data frames. So these are all the part of the RDDs itself. That is a resilient distributor. What is that? Data sets. Okay. Is this okay till now? So from the whatever we are getting the output, through which you can do a transformation and the actions. The transformation as we do in our SQL only, like you can convert from a map to a flat map. No, not to a flat map. We can do a mapping map of this, convert the data frames into a map or filter it. You can do sampling on the data frames. You can do group by key, uh, work group by based on a key. Okay, you can reduce it by a key, sort by a key, do an intersection of the whole data frames. Okay, and flat map, I think with the example it will be easier. And union of the data frames, join the frames, co-group, cross, map values, and reduce by key. All these operations are called the transformation. And what will be the action will be the collecting of the data, count of the data, uh, and taking the samples, save it, look up key, which is the first one, take order, all count by the aggregate kind of operations, or can be called as the actions over it. Okay, so these are the Spark operations which we will be doing it. Same like in your MR, where we do uh, a preparatory job for the data, and then we will have the reducer job, which does an aggregation or transformation of your data. Okay. So this is like a narrow or wide transformation. So this is, you can think of that you have a two RDD sets, which are the data sets divided, distributed in different clusters. So it, whichever is happening inside, if it is a map operation between a single key and value pair, then it is a narrow. While it is happening between the two distributed two RDDs in between, a group by key, an operation, a transformation like a group by key will do a transformation of, say for example, it is going to group a1. This is the data frame. Okay, this is the data frame. Okay, this is the data frame. So on this data frame we are going to do a group by a1 and a2. So it will consider these two information, and it groups by and gives a single result. So this is the wide range of transformation we can say. So between on a single cluster where the data RDD is present, which is the data set, if it is happening within that, then it is a narrow transformation. Otherwise it is called the wide transformation. Is this okay? So we can create the data frames using the operations. Okay, that I will show it with the example, then it will be understandable. Till now it's fine. Shall we move on? After that it's nothing. So actions are nothing but the final stage of the workflow, which gives the output for us. uh, Using Spark itself, you can write, you can do an ML job, or you can do any graphical work on that. Okay, it triggers the execution of the graph. So that's what some example also have written, like if there is, you are going to do a mapping of key value pairs, then you do an aggregation DAG, it creates it. So this directed acyclic graph is on, say, no. So each output is going to be the uh, mm, edge of it. This is the edge. And whereas the traversal from one position, the transformation to one form to another form, will be the vertices. So this is the vertices, and this is the edge. So this is how it creates it by itself. The architecture itself will create a DAG. Even for map reduce, DAG gets created, but we don't have to worry how it is created and all. Internally it gets created. You can visualize it when you start a map reduce job like this, and returns the result to the driver. So there is a driver architecture where it gives a driver worker, and many things are there. To that it will give the output for further processing. Just I will open that window also. Okay, 1 minute. Okay, that slide I don't have now. Okay, I will show it later. Okay. Then after that, it is the map flow. So this is the workflow. After the workflow, how it can happen and how the actions goes to the driver program is shown here. So this the data frames which will do a flat mapping, and after that it maps to the other databases where there can be, this is our RDDs, like RDD1, RDD2. Okay, so interchangeably if they are using between two transformation, this is the transformation process, and the final output which goes to the driver program is the actions. This is the action which it is written like this, and it goes to the driver program of the Spark architecture, and then it will be given to the user as an output. So Spark also has the worker, same like in our map reduce HDFS, and a master. Okay, when we install it we will see that. Sorry. Okay, that is all for this with the theory. I have another slide which talks about the architecture. I'll just check that. Just okay, I don't have that now. So any doubts in this? Only I have the content for theory. So we'll do the installation on Monday, Spark installation, and one or two programs. That's all, it will be done. Any doubts in this? Is it
Hello, ma'am.
clear? Yes.
Ma'am, actually, yesterday you asked me about the project that what is on what topic, and you were confused. Even I was confused. So I want to tell about the project. That can I tell you, ma'am?
Yeah, after this, ma'am, let me see if they have any doubts.
Okay.
Is that okay? Okay. Shah ma'am said no doubts. So this is Spark architecture. Any doubts? Anything is not clear? So it's say work same like MapReduce. We'll write one or two programs, then it will be fine. So people, can you in the meantime install Scoop and check? I will also do that. Okay. When you import the job, it will import it. Okay. So one other difference I can tell us. 1 minute. So now if you think of in case of Hadoop infrastructure or the big data, HDFS, Hadoop will comes with the uh, flavor of like HDFS, MR, Hive, Pig. Those two are used for the processing part. HBase, HDFS for the storage part. Scoop, Flume are for the data transformation. Like from Scoop is used for transforming from the structured data, whereas Flume and all can be Flume can be used for data transformation from other databases only, like inputting or outputting of the data. And there are two other things also like Uzi, Mehut, and all those things will do on the data analytics itself. Okay, in Spark, in order to change from the underlying map reduce jobs where it takes a lot of time, that shall be replaced with the spark infrastructure. Okay. Whereas for the data you can also, I mean, use spark along with anything, like whatever we serve, that HBase database, or any or data MySQL databases, or with the file systems distributed like HDFS, or the something like Apache, not Amazon S3s, and other file systems like standalone file systems. Standalone file system, I hope you now you can understand, like this Linux file system, which is the extensive file system, that one, or the Windows file system. So anywhere you can use the Spark also. So architecture of the Spark consists of, it has other layers also, where it can do ML jobs also, or the graphical jobs. Along with that, I showed in the slide, no. Mm. SQL queries it can write. It can also work on the streaming data. So when it is SQL queries and all, then you will think of the data frames, like the output which we are receiving will be the data frames. Whereas when it is an ML jobs or graphs, then it will be the pipeline output, because it will be of stream data, no. So that will be a pipeline output. So you can think of like that. Okay, is this okay? It's, is this okay, guys? Any doubts, please ask me. We will do an installation. Hope it works for me also. The thing is, I don't have a standalone now, so I'm doing it in the VDI lab, and there some setups are not allowing for some operations. Otherwise, it will work. Okay. No reply. Shall I stop the